In this exercise, we will create a simple three-dimensional enclosure that in X and Y direction goes from minus 50 millimeters to positive 50 millimeters, and the Z direction goes from 0 to 50 with a wall thickness of 2 millimeters, and we give it a user-defined material with a conductivity of 1. We'll fix the bottom surface of the enclosure at 20 degrees, and we place a heated component inside of the enclosure with the value of 0.25 watts. The component goes from minus 25 to 25 in the X and Y direction, and 15 to 20 in the Z direction. Is made out of copper. Here we want to create the geometry, apply the boundary conditions, create the automatic mesh, perform the simulation and post-process, and then we'll rerun the same model with including thermal radiation. Okay, we go ahead and create a model and give our model a name and save. This will automatically open the model parameters form. As we saw before, here we can set any global parameters as we see. For this particular model, we keep everything the same and press apply. Now we need to create our enclosure. Create geometry, choose enclosure. We want to go in the X and Y direction from minus 50 to positive 50 millimeters, and in the Z direction from 0 to 50 with 2 millimeter thick walls, and we give it a user-defined material, call it user01. Apply. Okay, now we created the enclosure, so let's go ahead and keep the bottom surface of this enclosure at the 20 degrees. So we go to boundary condition, temperature, pick the bottom surface, 20 is already there, and we press apply. Now let's create the heated wall. So we go and choose a cuboid, and let's say this goes from minus 25 to positive 25 in X and Y. And in the Z direction, we go from 15 to 20, and we choose copper for material and apply. So we created our heated wall. So we need to put some heat into this wall. Go to heated volume, click on the wall, we pick the solid, and we give it a constant heat of 0.025. Now to create the mesh, it's just a one button, and we click on it and the mesh is created. And now we need to create the material properties for our user-defined material user01, which appears in the form. Let's use a conductivity of 1 and everything else the same. And now, easy as that, we have created our model. We just go ahead and run it and press on run. So the solver windows will pop up and shows the progress of the solver. As soon as the model is converged, it will automatically load into the GUI. So here we have a converged solution. This takes us automatically to the plane plot form. As we saw before, we can pick any direction and scroll and see what the temperature and velocity or whatever else result quantity is. So let's go and choose the X direction, somewhere in the middle. Now we can click any point in the fluid or solid to see the temperature. So we have a 29.4 in the heated wall. Okay, now let's go ahead and add thermal radiation to this model. So we go to boundary condition, radiation network, and we will confirm that we want to include radiation and use the default tolerances. It merges all the surfaces, and we have now 12 radiation surfaces. To assign emissivity, we go in there, and user01, we have to give it a value, so let's just use 0.7, and okay, now we need to close. We need to click on the view factors and calculate view factors for these surfaces. And now when you run it, thermal radiation is also included in the analysis, so the temperature should be somewhat lower because we have an additional means for the heat to get out of the heated wall. So now we look at the result. We see the maximum temperature is about 25.8, which is lower than what we had before. With this, we will close this and save the model and move to the second part of this exercise.